Hi everyone, I am Mehwish Ghafoor and I am presenting my work entitled Quantification of Occlusion Handling Capability of 3D Human Pose Estimation Framework. This work is published in IEEE Transaction on Multimedia 2022. This is the problem definition. We have an input sequence of 2D pose that are partially occluded and we are trying to estimate the complete 3D pose. In first sequence on left, only 3 random joints are available and on right only 1 random joint available. We have also validated our experiment by missing all joints in few frames of a sequence. We have performed our experiments on 3 datasets that include human 3.6M, NTU-RGB+D and SYSU 3D human object interaction dataset. These are some results on human 3.6M dataset using our proposed T3D CNN using occlusion guided mechanism. Here on left we have an input 2D pose sequence with random 3 joints available. On middle we have our 3D pose estimations using our proposed T3D CNN and on right we have our ground truth 3D. These are results with only 1 random joint available in the 2D pose sequence and 3D estimations shown in middle using proposed method. Our occlusion guided method is performing well in complex poses for action purchases and action sitting down as shown here, whereas such a bending position is involved. To construct a model, we take a sequence of occluded 2D joints. We pass an extra information about joint visibility in the form of occlusion guidance matrix. We have proposed a method named T3D CNN that is fully convolutional architecture with residual connection that takes F consecutive 2D poses as an input and estimate 3D pose corresponding to central location of the input sequence. In order to compare the quality of the estimated 3D poses, 2 action recognition methods are used, including a simple baseline CNN and semantic guided neural network based method. In baseline CNN, we take a sequence of estimated 3D poses and pass it to ResNet 50 architecture for action classification, whereas for semantic guided neural network, we utilize both joint level and frame level information for action recognition. Here is a qualitative comparison on human 3.6M dataset with existing state-of-the-art methods. On left, only 3 random joints are available. On middle, upper body joints are available, such as knee and ankle joints are missing. And on right, 2 frames with high error are shown, with only 1 joint available. That shows our proposed T3D CNN is performing quite well as compared to the existing state-of-the-art methods. This is the qualitative comparison on NTU-RGB dataset. On left, we have only 2 joints are available, while on right, we have 4 joints are available. And here is the comparison of T3D CNN with the existing state-of-the-art methods. These are some quantitative comparison with partial random occlusion on human 3.6M dataset using mean per joint position error. Some more quantitative comparison on human 3.6M dataset with fixed occlusion in 2D sequence. Also, there are results with missing all joints in consecutive 1, 3 and 5 frames as shown here as T1, T3 and T5. Proposed T3D CNN has shown improved performance. Quantitative comparison on NTU-RGB+D dataset. These are some results on SYSU 3D dataset and we have also validated our experiment using 2D detections and confidence score as occlusion guidance. The following curve shows action classification accuracy of estimated 3D poses using SGN. On x-axis we have available joints and y-axis shows accuracy. Estimated 3D poses using the proposed T3D CNN have shown improved classification accuracy under occlusion scenario, whereas performance for predicted 3D poses by using video pose 3D decreases much faster as the number of missing joints increases. In this work, we introduced occlusion guidance based on temporal dilated CNN for the estimation of 3D human pose in the presence of sphere occlusion. The proposed method outperformed existing state-of-the-art methods using random missing joints, fixed partial occlusion, and completely missing few frames. For a future direction, one may integrate a tension mechanism with our proposed occlusion guidance to better estimate 3D pose. Also, occlusion handling in wild and occlusion in complex poses such as sports one are still open problems. Thank you.